Hello everybody, this is Great Math number 106 with me, JP, and today we're doing yet another math video, and I think this is going to be our last inequality video. So here it is. Final values of x, such as 4x minus 5 divided by 3x plus 5 is greater than or equal to 3. This seems like an easy problem. Well, why am I doing it for the last one? Just wait. So, okay, so first just what we do, we hate the fractions, so we try to put them on both sides. We get 4x minus 5 is greater than or equal to, multiply by 3, 9x plus multiply by 3 again, 15. Like terms together, minus 4, that becomes 5, minus 15, it becomes negative 20. Divide 5 by both sides, you get negative 4 is greater than or equal to x. We're not done though. Let's think of something. I want to make sure I'm right. So, this is the last inequality. I want to make sure I'm really right here. So, how would I do it, right? Let's see. Well, maybe I can check for the answer. I'm gonna look for an answer that's wrong, and it shouldn't work, right? Let's just try. So let's try negative 3, because in this case, it's negative 4, negative 5, negative 6. All of those work apparently. So let's try here. So negative 3. So it becomes negative 12 minus 5 divided by negative 9 plus 5 is greater than or equal to 3. Negative 17 divided by negative 4 is greater than or equal to 3. Cancel those out. The minuses, we get 17 divided by 4 is greater than or equal to 3. That works because 16 divided by 4 is 4. 4 is greater than 3. 17 is just a little bit more. But that works when we did negative 3. That's not in the equation. Something's wrong here. How do we know? So, okay, so let's think back to our simple steps, okay? But then we get to a point that we remember. If you multiply by a negative number, the sign should switch, right? It should do that. What makes us think it's negative? Well, okay, so any fraction, obviously this is positive because it's greater than or equal to 3. 3 is positive, anything greater is like 100, it's still going to be positive, right? So let's try A over B. How do we make this positive? Well, both of them have to be positive, so A has to be positive, so A has to be greater than 0, and B has to be greater than 0. But then, what if one of them is negative? And that means the other one is negative, because it cancels it out, right? So if A is negative, B is negative, you have to cancel them out. You cancel out the negatives to still make it positive, right? So this could be meaning, because we have no clue what x is, this could be meaning that 3x plus 5 is a negative number. So when we multiplied it on both sides, the sign switched. So that means the one that we just used right here is if it's positive. Let's try one if it's negative, okay? So 4x minus 5 is now less than or equal to 9x plus 15. Okay? Because when we multiplied it, it switched, right? So we minus the 4 here, it becomes 5x again, minus 15, and becomes negative 20. It's greater than or equal to 5x. Then we get the same answer, almost. Only difference is the sign switch. Okay, now I already put some work just trying to make sure that this is right. How do I actually make sure that this is right for good? Well, I'm going to try something that works. I'm done trying stuff that don't work. I want to make sure it works, and I want to try something that works. Okay? So, how are we going to do this? Let's try 1 because it's easy to do. Anyone can do it. So, we'll try 1 in this equation because it's greater than negative 4. So, let's try it. 4 minus 5 divided by 3 plus 5 is greater than or equal to 3. Negative 1 divided by 8 is not greater than or it's even a negative number. It's not greater than 3. Okay, something's wrong again. Okay, let's think about this. Let's think all the properties That must work. Okay, so you multiply negative, the inequality switches. Then we go really basic. That gives us an idea. A fraction can't be possible, and this should be, you should always think about this when you're doing linear equations. If you're dealing with fractions and the variable's there, the variable cannot make the bottom part 0 at all. But then when we do this, it does make it 0. Why? Okay, what's 3 times x needs to equal to -5 in order for it to be 0, in order for it to not to work. So what is that? That is -5 over 3, because the 3 cancels the denominator. It becomes -5. So -5 plus 5 is 0. That doesn't work. I'll even show you. So 4 multiplied by -5 over 3 minus 5 divided by 3 times -5 over 3 plus 5 is not, we obviously know it's not greater than or equal to 3, but we'll just try it anyway. Okay? So, -20 over 3 minus 5 is divided by -5 because it cancels out, plus 5. That equals to 0, and that means it doesn't work, okay? So, that gives us one thing that doesn't work, so why didn't the 1 work? We think about this a little bit more, and we finally get our solution. We'll think about this a little bit more, yeah? And here's our solution. So, we see that, okay, so this works only because of -4. Because if you try it, this equation, you can even pause and try it. -4 does work in this equation. But anything less than -4 does not work. So, that means this is not completely right, because 3x plus 5 is negative. So that means the numbers that x can be has to be negative, right? So, that also means that we made sure this is right until a certain point, because this works for several numbers. So that means -4 is greater than, or less than or equal to x. But then it can't be -5 over 3. So then that means it must be less than -5 over 3. And we already have our solution right here. How did we build this? Well, we thought about -4 is less than or equal to x. Okay, so that worked until a certain point, which was -5 over 3, because you could try 2. You could try 2, that worked. -2, that works. You try -1, it doesn't work. So in between that, which is -5 over 3, doesn't work. So anything less than that does. Besides, until you get to -4. After -4, right here, it doesn't work anymore, right? So we have that system of numbers that only does work. So we don't have a few numbers, and that's why they said find all values of x. So we're not going to write out every single number, like -4, -3.9999, -3.9998, -3.997. We're not going to do that. We already found our simple equation, or not equation, our simple system. So we have our values of x right here, because anything that works, you can just plug it in. It works as long as it's less than or equal to -4, and it cannot equal to -5 over 3. It can be less than it, but it can't be equal to. Strictly can't, or else it will be 0. And I guess that wraps up our inequality chapter. I hope you guys liked this video of great math. This is number 106. I hope you guys liked it, and I'll see you next time. Goodbye.